In this video, I am hoping to take what I've done so far on my 386DX, which is get it powered up. Looks like I'm seeing things move a little bit as far as signals, so it looks like I'm getting stuff, different addresses coming out of the processor. And I want to be able to see that data on my PC, basically use my PC as a way to visualize that. Now to do that, what I'm going to use is a Teensy. This is a Teensy 4.1 here that I have, and that's what I'm going to connect basically as the bridge between this system and my PC. Now the reason I want to give this a try is that it supports high-speed USB, so I think that's 480 megabits per second. My last debug setup, instead of a Teensy, I was using an STM32, and that had a limit, at least with the native hardware, without extra hardware that I'd have to go purchase and add on to it. But with the native hardware, was limited to full speed USB, which is maybe something more like 12 megabits per second or something like that. It's not real fast. So I want to get up to this 480. Now a challenge with this, though, compared to the STM32 is I don't have enough pins. So if I want to grab all my address, all my data, all my control signals, I probably need 100 signals coming in. This does not accommodate 100 GPIO pins natively, so that's something I'm going to have to then do something with. So what I previously had shown is that I'm going to use a little carrier board that I've put together, and essentially this Teensy will sit on it, and then I need to bring all my signals in to some pin headers. Now, these signals are not enough to cover 120 some off of my 386 board. So what I'm going to actually do is bring in some signals using a different card. And this card will plug into this slot. It'll read, in this case, the 32 address signals, and then it will shift them and serially send them over to the Teensy. And so I have 4 shifters on here. And those shifters are 74 165s. So I have a roll of those ready to go. Now one problem I ran into right away is that this board that I built, the footprint ends up being a wide body footprint as far as I can tell. So I've gone back and tried to figure out why these ICs don't fit that, and it seems like these are kind of a standard width for the body, and these, for some reason, they weren't marked, but they appear to be a kind of more of a wide body. So that's not going to work for me, so I'm going to set that aside, and I have an updated revision of that. And so now I have this little card, and this card should accommodate these ICs that I have here, these surface mount chips. I'm going to have to surface mount 4 of those on there. So each of these chips can handle 8 bits of data. I'm going to plug it into this physical slot, which is a PCIe, so PCI Express X4 slot. And a couple of these, well, 3 of these cover my data and control signals. So this one covers my address signals. So I need to get 4 of these 74 165s populated. I need to get the capacitors to go with those ICs on there, and then I need a small ribbon cable, basically a pin header, that will connect over to one of these 4 locations. And then this will insert here. I'm not going to push it in all the way, but then the ribbon cable will come over here and connect. And then what I'm going to do is manage the serial transmission from these 165s over to the Teensy from the Teensy. So the Teensy will generate the appropriate signals to do that shifting, or basically control these 74 165s. And I can pull signals off of these pins basically for these slots, these PCI Express slots. And again, I'm just doing the physical connector, so it's not like I'm using the PCIe Express, any protocol or anything. It's just a physical connector for me. But I can pull it off of that and read those in, or I can use these pin headers and directly just connect signals there from wherever, and use this kind of as a standalone, just a way to connect up signals that will then go through these shifters through the ribbon over to the Teensy. Or I can use this little card as a breakout. So if I have these debug type of ports on any of my builds moving forward, this card I can just simply plug in and get quick access to all the signals through these 2 pin headers. And these pin headers are really set up with a lot of grounds in them, and that's why there's so many pins. So there's more than 32 pins there, of course. So that's one thing I've got to get done, is I've got to take this. I have to get these 4 of these surface mount soldered onto here, along with 4 capacitors and this header here. And that's really all I should need for the time being. Now, other changes from this version that I had to this version is my copper fill. Something weird happened. The top side, the copper fill didn't get filled in, and the bottom side I got a couple of weird spaces of copper fill, but not where I would expect it. I corrected that. I'm not sure what even happened on that one, because as I went back and looked at it, something with how maybe I didn't rebuild the copper fill, or there was something anyways that wasn't right. This one looks good. Looks like I've got good copper fill top and bottom. I'm doing one copper fill with VCC. I'm doing another copper fill with ground. So I'm hoping that this will work out as a decent little card to plug into here. And if I do eventually get this working, then I'll come back and populate these others, populate 3 more of these cards. They'll all plug in, and then the 4 sets of ribbons will come over here and plug into this. So this little carrier, again, is just going to hold a Teensy, so that'll sit on there. Now, you'll notice I have 4 ICs on here, though, so I still have additional ICs that I'm going to have to use, and that is these ICs here. And so these are 74 LVC 8T245s. Basically, those are going to let me do level shifting from 5 volt to 3 volt. So, the system, of course, is a 5 volt system, but the Teensy is a 3.3, so a 3.3 volt system. And you cannot directly connect those. You will damage the Teensy. And the way that I'm essentially doing it is I'm going to use these level shifters on this card, but this card here is just going to do these 74 165 shift registers. So I'm going to stick with 5 volt. This is going to be 5 volt. It's going to send everything over to here in 5 volt. And then all the 5 volt incoming signals that I'm reading from over here are going to then get translated to 3 volt through these right here. And so I've got 3 of these that will handle all the incoming signals, and one of them is taking the 3 from my Teensy and converting it to 5 volt. And that's really the control signals. So these 4 shift registers need to be controlled. I need to send it a clock, basically a serial type of clock, and a couple other control signals, but that's all going to come from the Teensy. So the Teensy will generate those signals. It will basically shift them up to 5 volt and then control these, and then everything that's reading back is going from 5 volt back down to 3 volt. So that's the intention. So this is my Teensy carrier board. I'll solder that onto here. And as I look at that, I'm taking a guess at which pins I'm going to use here. And you're going to see that I have a bunch of these that come out to maybe some headers. Maybe those are pins I'm not using up front that I might want to use later. I also have some of these other pins going out to basically a jumper that I'll put in here, so that if I decide I don't like the way the signals are coming from here, I could take off the jumpers and do something different. Anyways, it's just some flexibility for me as I get into this. I've not worked with the Teensy before. I'm making a whole bunch of assumptions on which pins I can use and how I'm connecting them up. And I just simply ordered the PCB without doing any prototyping or breadboarding or anything like that. So we'll see. That might completely backfire on me. If you're seeing this video, I'm hoping at the end of this video there'll be a happy story, not a sad story about this working out, but we'll see. So to get me going, I need to get this populated. I need to get this populated. These ICs here won't really be too bad to solder on at all. These are pretty small, so I definitely am going to get my microscope out And I think, my experience with these, especially when I do copper fills or 4-layer boards with ground and VCC in the middle, my hot air gun and a hot plate seem to make it the quickest work of this. I have an IR oven, which works fine, but it seems like if I take a hot plate, get the board warmed up on the hot plate, and then use my hot air station basically to actually do the solder on this, that seems to work quite nicely. So that's probably what I'm going to do with all of these 4 and these 4 here. And if I can get that all done and get capacitors and headers and all of that stuff put on these 2 boards, then I will transition into just doing some testing. Can I read out, from this, pull it into the Teensy, and from the Teensy try to show that output maybe on my PC. So eventually I'd like to get to the point where I'm showing the waveforms and the data on my PC. But we'll see if these are going to work out for all of that I'm going to do. And along the way I can do some testing, so I can probably bring in some 3 volt signals. I have some little test boards that let me quickly set values for debugging purposes, so I can just bring in some values, flip some dip switches, set them, see if I can read it correctly. So I can debug this or validate this card works by itself with this Teensy. This one here, same thing. I should be able to just do some really basic type of testing with it, but I'm not real worried about it. If I can get this connected over here, I'll find out quickly just by controlling from the Teensy if that's going to work out or not. Okay, so that's where I'm at. I'm going to go ahead and move all of this stuff off my workbench because I don't have a big workbench. I think I'm going to pull up my microscope, get out the hot plate, and probably start with getting these 4 ICs on each of these PCBs up and running. Okay, soldering is done, so hopefully this has turned out okay. The best I can tell, things are looking okay. There is a spot here where some of this top mask came off, and both of these pins are ground. So if you see this little blob here, it's just those 2 pins, and where this mask came off is just one big kind of a solder location there. But other than that, I think the soldering went okay. And so I think what I'm going to try to do next is see if I can get some code on the Teensy here that will see if I can validate, can I shift something in from one of these shift registers. And I'll probably just manually set some signals on these pin headers and see if I can then read those in. And if I can read in all 32 bits there through these 4 ports, these 4 voltage level shifters, then I think I would be comfortable getting this plugged into the 386 and see if I can do the same thing. So that is what I'm going to come back with. And so I'm going to go ahead and clear off my workbench and come back with trying to get some of this up and running. Next step, if I want to eventually get plugged into this board with this small card into my PC with this card, I'm going to have to make sure that I'm reading signals in, I'm shifting them correctly out through this header, that this Teensy can do all of the control of those shift registers. All of that's got to go through the level shifters here and get me my 3 to 5 volt conversions. I grabbed this little bus debug board that I have. This is going to let me basically set 16 values. I'll probably just use 8 at a time, but set 8 values. I'll be able to see what values I've set. And then with this header, I can just plug into 8 inputs here that'll go to one of these shift registers. So I can set a value and then try to shift that out and read it on the PC through the Teensy. And if that works, then I can kind of rotate through all 4 of these to make sure all of these level shifters are working. And then, of course, I can shift pins to the 4 different shift registers just to make sure that's all coming through okay. So I should be able to pretty much fully test this with the help of this little board. And, of course, getting the right coding, whatever I need to do on the Teensy. And I've done that with the previous board with an Arduino Mega, and I believe I can use the same development environment to work on this. So that's what I'm going to have to get into here shortly and start working on that a little bit. But before I can do that, these cables here, I'll just use basic cables like this. So these DuPont style connectors or cables. So I will be able to come in here, grab 8 of these, plug it in here, run them over to the appropriate input pins on these headers, which correspond to all the pins on this little PCI Express connector. And then from here to here, I suppose I could also run these same type of DuPont cables, but what I'm going to do instead is just use a series of ribbon cables. So I've got a spool of ribbon cable. I cut off this length, figuring that it's probably the worst case scenario. So if I have this all the way over here, and I'm going to plug in a header there, and then plug this in over here, that gives me a little bit of slack and should be the longest that I will need. But I'm going to get 1 cable made, and that way I can connect this to this, and then I'll use these guys to connect from here to here. And then I can set values and then hopefully figure out if I can program this to read those values by controlling the shift registers over here. Okay, so that's what my cable looks like at the moment. So I've got pin 1. It's got a little designator of a triangle here. And then on this side, my pin 1, same thing. So if I've got that right, I might not have it right, but I'm going to go with it. So on this connector, I might just say, okay, let's do, I might prompt these facing down. So I'm going to go like this. Okay, so then that'll end up plugging in here. If I want, of course, I can have it face up. Well, maybe that's the way I want to end up going in case I've got other stuff in here. Okay, so that's going to plug in like so. And then I've got to bring that across and just make sure I connect up. So real quick, I'm going to look at the schematic on my system. And what I want to make sure is that when I look at this Teensy little breakout, so I'm going to go from PCI Express to my little Teensy probing board is what I've labeled it. Let me come down to that. As I look at that, and I look at this pin header, I've got the kind of a VCC and a ground over here. So VCC is on the far left side. So if I'm looking at this board like so, these far two pins are VCC, and then I've got a pair of grounds. And so when I come over here, I want to just make sure that I don't plug this in backwards, and maybe at some point I'll have to, cut a pin cut one of the ground pins and put in something that prevents me from putting it backwards, or of course add silk screen to it to make it really clear how I'm going to orient this. But I now know that the pink here on this will be my VCC side of this, and so then I'm going to go over to my Teensy debugger, this. And if I look at that, VCC I can see is down here, basically on the bottom side as I'm looking at the board like this. So that means that pin 1 is going to have to be down here like so. And 4, 5, 6, 7, I don't know if it really matters right now. I'm going to just grab P4 for this. So what that should give me is connecting, and this should be pretty easy to remember, that if I'm reading the silk screen as it is, pin 1 is always on the left side, so the stripe always needs to be on the left side of any of these connectors. So that's, I guess, pretty easy for me. I should be able to remember that. So I now have this. I can then turn around and maybe grab 8 wires here and just plug that into my little debug board. And I will have to get power to this board yet, so that'll need a little 5 volt. And then this will pull power through the USB. Okay, so I'm going to only use these 8 bits, so these dip switches will let me set these. I'm going to take the far right and treat it as bit 0 or address 0, so that's what I've got going to address 0, and as I work my way left on these, I'm going up the address lines here. So basically I just pulled this and turned it as it comes over and connects. I've got to get ground, and I probably should, ideally over here I'll have many grounds, so all of these grounds will be connected, but for now I'm just going to go ahead and grab one ground over here. Okay, so then let me get power to this, then I can set some values, and then I've got to get code on here. But otherwise, I think my physical connection is looking okay. For power, I'm just going to grab one of these little utility boards I've been using so I can bring power in here, just using my same old banana connectors that I've always been using. So turn the power switch off here. So power will come in here. I've got a switch and a relay to power the rest of this board. And I'm going to bring in power and ground, which I'm going to just pull off of a little header. I've got a bunch of these just headers that I can plug into, whether it's this style hot connector or these blade connectors or just some plain old basic pin headers. But this seems close enough. So red is my positive. Get my ground connected. Okay, so this is off, so I should be able to turn on my power supply. And actually here I could send a clock signal through if I wanted to, and maybe I'll do that just so I have something. Okay, so I'm going to grab a clock signal over here. I'm going to set this to use a slow 555 auto clock. And then again on this, then I've got to feed it a clock, and let me go double check the pin on that again. So here, I should go to this. So this middle pin right here is what's going to get essentially sent through the ribbon cable over here. So I now have like a real clock that'll be running from this. That clock, 8 values here. Got my power, 5-volt and ground will come over here. I got to get this plugged into the PC and programmed. But I think that is the route that I'm going so far. Okay, so I'm going to go ahead and plug into a USB port up here and turn on power to that port. So I've got my 5 volts coming out of that okay, and I believe this is power and data in this cable here. And so now I should be able to plug into this and start to try to use these pins. And if I go over to this, what you're going to see is this Teensy. And so I should be able to put this in here. I got the right connector and try to get some programming going on that. So I think what I'm going to do for now is, just for safety, I'm going to pull this off, isolate all this, and focus on getting this working. Okay, 0.067 amps, so it's pulling current. I see that's flashing. I know nothing about the Teensy, but I'm going to assume that's just kind of pretty normal. And I'm going to stop here and get my programming environment opened up real quick and see if I can then start to do something on here and start to port over the code that I previously had written. And I'm hoping that the code that I had written for this debug board should port over to that pretty easily, but we'll find out. This is a very similar type of setup as this. It's just, instead of this Teensy, I was using a Mega. So an Arduino Mega, and pulling all the signals off the Isobus. And this, of course, would not work for my higher address bits or top 2 bytes of data, but for the 16-bit data and the address on an ISO slot, that I could pull with this. This was all shifting it in, very similar to what's happening over here. Here I've got 4, and then you can see I have more than that over here, of course, but I'll have 16 of these once I get all 4 of those populated. That was then coming into this Mega. I didn't have to do any voltage leveling because this is a 5-volt 5-volt device, so that was one handy thing there. But the code I have on this, I'm hoping, will be able to either directly load onto this in the Arduino or the dev environment I'm using, which I'll get that pulled up and walk through that, or the code at least. I've got the framework for what I need to do, and we'll just have to figure out how to do it on the Teensy specifically. Okay, fast forward a little bit here. I've created a Visual Studio project, and in it I am going to edit essentially an Arduino project. And that Arduino project is going to help me write code to manage and really run on the Teensy board that I'm using. Now, to do this, you have to have an add-on for the Arduino IDE to support, I think it's called Teensy-duino, but it basically is just the board support files so that you can use a Teensy from the Arduino IDE. And then instead of using the Arduino IDE, I use Visual Studio. So in short, I'm using Visual Studio to manage code for my Teensy. And the first thing I'm going to do is define some pins. What are the different pins I'm going to use for loading my shift register, to clock the shift register, etc. And if I jump in my system over here and look at the schematic, here's the schematic for this small PCB that I have that's hosting my Teensy. And you can see pin 0 up here to the upper left. That should be this load signal, and pin 1 is my clock signal, pin 2 is this inhibit signal, and then I have all these other every shift register that I'm going to use. I'm going to support up to 4 of them for the acquisition boards, each with 4 shift registers. So 4 times 4, that's 16 shift registers that I'm going to be able to support. They each need their own pin. And so I'm defining all of those pins over here in the code. And so if I jump back to the code, That's all I've done is just said which pins are going to be used for what purpose. And then I have a little setup routine, and in the setup routine, I just simply set a few of these as outputs. So again, the hold, the clock, and the inhibit, or sorry, not hold, load. This is a shift register load, clock, and inhibit. Those three signals I'll need to control the shift registers. And then as I'm using those, I can read out of the shift registers through a pin like this one for shift register 1, and I have all 16 of those. So all of those will be inputs into the Teensy coming from, really the acquisition board that has the shift registers. And then I have a testing little procedure that I've kind of copied over from my previous Arduino Mega work where I was doing something similar. And I've kind of just stripped it down just to do some testing real quick. And I have that procedure called read serial. I have another procedure I'm working on called print port values minimal, and I have a loop. And so for now, what's happening is when I want to run this, it's going to say go to this procedure called print port values minimal, and it's going to end up calling a read serial. Now this is a bit messy right now, and it'll get cleaned up later. But what I'm going to basically do, and I even see some code here I definitely don't need at this point, but this is going to call a read serial, and read serial is going to modify those signals for my clock inhibit, the clock, and the load. And so I go through a sequence here, and then that basically gets my data loaded in a parallel fashion into the shift register, and now I just need to cycle the clock to read out the bits. And so I have a quick loop here, and I'm just going to run through it 8 times, read those 8 bits. And I'm doing some quick testing. All I want to do for now is read 8 bits of data and see, can I read 8 bits in? Does it work? Eventually, I'll read the entire 32-bit address, but for now, I'm going to read just a single bit of 8. So I'm going to read 8 bits, and I'm going to pick one of the shift registers that I'm going to test. I'm going to read all that in, put it into this address 32, basically in the lowest byte for now, and then I'm going to try to write that out to my serial over here to the right, this little just serial monitor. And when I get through all of this, though, of course, instead of reading 1 byte, I'll read all 4 bytes, and I'll have a full 32-bit address that I can output if this all gets to the point where it's working. But I wanted to kind of show some of the work I'm taking along the way here. So now if I jump over to what's on my desk, you see over here I just have this little card running for power, and it's running a clock, which is not hooked up to anything. I'm not even bothering with this clock signal yet at the moment, so maybe I'll just pull that off of there. But what I do have is, again, this Teensy debug board, and on it, I have those level shifters for the voltage. I do have this cable connected over to one of these little acquisition boards, and the idea again is that this would plug into my 386. For now, though, I'm running a ribbon cable to this board that lets me just simply manually toggle on and off values. And what I can do then is just set a value here and set it to one of basically the 4 bytes. I have 4 of these shift registers, so I'm going to assign it by connecting to the appropriate physical ports here. And then see if I can set values, and for that shift register, for example, right now I'm connected to the pins that go to shift register 4. If I turn on values down here, do I shift them in correctly, and can I see that on the output on my screen? So right now, let's see, do I have things powered up? It looks like I do. I'm going to clear this debug output real quick, and you can see it's just right now running its loop, and that's back down to this code that says, print minimal values, and all that's doing is calling this read serial. Read serial is reading the bits from the 4th shift register. And if I look at this acquisition card, I have pins for register 1, 2, 3, and 4. So I'm plugged into register 4. And then down here, I'm going to go ahead and basically flip on a value. So if I flip on the lowest value down here, you see an LED. I don't know if the camera will pick this up, but it shows that that bit is on. And now in my output, I'm seeing that value of 1. If I add the next bit to the output, you can see I now have a 3, and then I get up to a 7, 15. So there's my or F and hex, of course, is what I'm outputting. So let me turn those off again because it looks like one of these I didn't quite have the dip switch all the way down. So I'm back to 0. There is my 1. There's my 3, 7, F. And then if I flip this next one over, it's going to give me a 1 in that position to the left. So I now have a 1F. And then I should be able to go to a 3F, 5F, or sorry, 7F, and then FF. And so I can see those are all working. Or if I want to do alternating bits and look for certain patterns, like here I have an FF, a 5-5 is what I'm outputting. If I was to swap all of these around, okay. If I was to swap all of these around, what you're going to see then is the value of AA. So often you'll see people use 5-5 or AA for testing purposes because it's alternating bits. But anyways, all bits off. I'm reading my 0. I can add the first bit from the left. There's my 80, and I can count up this way. So C, E, and then I get my F, and then continue it here. There's my 8. There's my C, E, and F. Okay, so all that seems to be working. And I'm on the 4th shift register. I already went through the other 3. They're all working. So I know that this acquisition card here with the 4 shift registers, I think is good to go at this point. It's reading those values. The way I'm going to be using this initially, I'm not even going to bother with this clock or this clock over here. That really isn't going to matter for this setup. So I'm not going to use these pins for now. And again, these pin headers are just for debugging like I am right now, manually with just cables run. But what I'm hoping is that this instead will just plug in, and all 32 signals would be read off of the little PCI Express edge connector. So that's all coming over into here, and this is one of 4 ports that I can connect. And so if I wanted to, I should be able to use the same acquisition board and then come over and just test it and see if I plug it into port 5. And so then I can go back and say, okay, if I was going to plug into port 5 then is going to give me shift registers 5, 6, 7, 8 if everything there is okay. And so what I should be able to do in theory is pull this, come over here and plug it in carefully, not to be off a pin. And then take this code and say, okay, I want you to read shift register 5 now. Well, actually it'd be 5, 6, 7, 8. So maybe I'll do shift register 8, which should be that same one it's already connected to. And I will see if I can run this. What doesn't it like? No, okay, I can ignore that. Okay, so it shows it's outputting FF, and that should be right, but now let me drop out some values here. So, little bug in this user interface. I have to resize it to show it correctly, but there's a 7F, and I should just be able to increment my way down. 3, 1, 0, 7, 3, 1, 0. So that's all good. And if I go alternating bits again, there you see my 5-5. Okay, so it seems like that tells me that the voltage leveling for this port is working. So I got 2 of them validated. I was using a scope. I'm going to set that off to the side. So then I could go to port 6 and do the same thing. And that's going to let me test the next level shifter here. So if I'm on 6, and I go back over here and I see 6, that should give me 9, 10, 11, 12. And I'm just going to grab then 12 and run that. So again, 12 will map to this 4th shift register. And I know the other 3 work. So really all I'm testing is this port over here. And I'm getting a 55 right away. That's good. So let me flip all these off, make sure I get a 0. And I'm just going to count my way up. So there I'll add the 1 bit. And there's my, again, I have to resize this every time I rerun it. 3, 7, F, 1, 3, 7, F. Okay, great. So then I now have 3 of these tested, so I might as well test the last one while I'm here. Okay, so that last one should be my shifter 16. It's the last one. And let's just see. I've got all ones here, so let's see if I get FFs. It looks like I do. And let me drop this all to zeros. And okay, good, all zeros. And let me just go up 1 bit at a time. So there's my 1, 3, 7, F, 1, 3, 7, F. Okay, so that means at this point I have an acquisition card that is working. If I wanted to test the other shift registers, I would just pull this. And if I come down, for example, to these pins, this would be the first shift register. And in this case, if I'm connected to this port, that would be, what, 13? So 13, 14, 15, 16. And so I could real quick do a test with that just to make sure that that all looks okay. I'm expecting FF on this. And then again, I can, flip these off and get back down to 0. Okay, so that's all working. But I could repeat that process for the others, which I had already done. So I know all 4 of these shift registers work. I know all 4 of my voltage leveling is working. And to clarify on these, 3 of these are used for input. So I'm reading a total of 16 incoming signals. And that means that I need to have 8 on one of these, 8 on the next. And actually, let me go look at how I've got this set up. Show you this for a second. So here are, let's see, let me get to the right project. Here's my Teensy Debugger, and here I have these level shifters, and you can see that when I'm down here, I have 4 here, 8 here, 4 here, plus this clock debug, and then another 3 here. These 3 are outbound. These are outbound signals from my Teensy over to the shift registers to send them, again, those control signals. And then down here, I've got 4 bits, 8 bits, 4 bits for the 16 shifters. But I had one more, this incoming clock debug, because I might want to know when to set up an event or a trigger, basically, on this based on a clock, incoming clock source. So I unfortunately needed one more bit coming in. That's 17 bits. So I couldn't get away with 2 of these level shifters. I needed 3. And this is how I ended up distributing them across those 3. This other one is going the other way. Now I could have used a bidirectional level shifter, but I will say I've not been as happy with those. I mentioned that in a previous video. And this single direction, unidirectional level shifting is working great for me. So all the testing I've done so far, I will say this Teensy has been great so far. Just worked as I expected, very simple, didn't have to do anything fancy. It just treated it pretty much like a Mega or a Nano or any other Arduino. That was not the case for the STM32. That ended up being quite a bit of hassle to make that work the way I would expect it to work out of the box. And it just can do a lot more, but it was not, at the end of the day, the easiest thing to work through and debug and work with, whereas this is just working, and this is great. These level shifters, my shift registers, all of that seems to be sitting pretty good right now. And so I'll be able to pull off this test. I know I'm good on this card. I will have to produce 3 more of these cards quick. So I will populate 3 of those. I'm going to do that off camera. You've seen me do 1 of them. Seeing me do 3 more won't be the most exciting thing. But I'm basically running this over here. And if I set some values here, you can see whatever values I've set. So on, off, on, off. That's giving me a CE. And so that CE is being read, and I'm reading it at a certain speed. One of the challenges I had with the STM32, again, was just how fast could I run USB. So this right now, I should be able to run if I go, I don't know if it even reads or pays attention to my USB speed in the serial begin, but I should be able to, in theory, run that up to 480 megabits per second. And I'll do some of that testing later once I see that I'm actually reading all 32-bit values here, which, for me to do, if I want to add the next 16, for example, I can do pretty easily. And maybe I'll do that here real quick just for the fun of it. But once I get all 32 of this working, plus the other 3 cards, all 32 of those working, then I can put all of this together into a string that I send to my PC through this serial USB, and I can do that at the 480 megabits per second. If I do want to get these other 8 bits working, real quick, I just need to find another cable that's an 8-pin cable to connect that in. Okay, so just in my box of cables here, I have this one, so it's a 5 plus 3, so that gives me my 8. And then I will go ahead and connect that in here. And let's see, make sure I get the orientation right. Okay, so now I should be able to connect in, and maybe I'll just set this to alternating bits for now. So now I'm adding another 8 bits to my data. That does mean that over here in my code now, I do need to update this a little bit. So the address is going to be, this, if this is going to be my bottom 8 bits, I want to add something to that above that. And let me just do this. This will be similar to the code that you see up above. Okay, so read shifter 13. And I'm going to go ahead and pull 13 plus shifter 14. And shifter 14, I can decide which of these I want to be, my higher or lower bits, but maybe for now I'll just make those be my lower bits and this other one be my higher bits. So read 13 in, treat it as the highest bits. Read this next one in, treat it as the lowest bit. So that's my high byte, low byte. And essentially, I'm going to read that in. So read the bit in and shift it. Basically, every time I read a bit, shift it into its appropriate location in this address variable. And then write this out. So let's see if I've got anything wrong with this. Just doing this really quickly on the fly. Okay, so yeah, there I got my CE55. I should be able to turn off all bits. And there's my, okay, now I'm only getting 0, 0. Let me, in my output, make this be 4 characters. Okay, so now add on my lowest bit. Add on my highest bit. Okay, that's good. So I'm going to go back just to my lowest bit, and I'm going to just kind of keep adding. Now, if I want to just do 1 bit at a time, there's my 1 value, and there's my 2 value, 4, 8. There's my 16, or it's flipped over to the next hex, so that's 1 carried. And then we get 2, 4, 8, and then 1, 2, 4, 8, and then the last 4 bits here, 1, 2, 4, 8. Okay, great. So all 16 bits on this debug board are working. If I wanted to test the other 16 bits, now this debug board, these others are for reading back values. I can't assign values, but I have more of these boards. So I would just go grab another debug board, plug it into the others here, and then I could assign 32 bits through my 2 debug boards, these, and read them all through this one card. if I want to quickly test just these other ports, I would just pull these up and connect it to the upper header, which goes to the other two shift registers. And at that point, if I'm on the other two shift registers, instead of me doing down here shifter 13, 14, I probably need a 15, 16. And I'll go ahead and run that. Let's see, I've got all the values off. And I'm just going to quickly flip these on and just make sure that as I go. So there's my 1, 3, 7, F, 1, 3, 7, F, 1, 3, 7, F, 1, 3, 7, F. Okay, so now I'm doing 16 bits on the other pair of shift registers. So obviously all the bits are working. So all 32 here, and I've gone through all 4 ports here. So each of these ports can fetch 32 bits off of these 4 input shift registers. So I've got 128 bits that I am capable of reading. I could easily expand this to more than that. Adding a couple more of these small ICs and a couple more headers is all it would take. And if I go back to what I'm using for pins here, I have these 4 pins available for sure, plus all these pins, plus all these pins. So I could add as pretty much more than I will ever need for input pins on the shift registers. And then, of course, processing speed. How fast can I actually read all the signals? Because for every time I want to pull the value, I've got to run 8 serial clocks, shift-in clocks to get the values, and enumerate through all of these and read all of the values, put them into an appropriate placeholder, variable, etc. But this appears to be working. So I think what is next for me is, again, I need to build out 3 more of these, and then just update my little Windows app. So some of you have seen previous videos where I'm using a little Windows application I wrote that shows me the kind of the histogram, the logged values graphically, so I can kind of see it like an oscilloscope or a typical graphical logic analyzer output. Plus lets me see all the raw data in a window below that. And previously where I was running into a bottleneck again was back to USB. So now I want to see if I can just simply pick up the speed. And I'm pretty sure the PC, the rendering of that user interface, will be the next bottleneck. But I want to kind of see how fast can I go, or maybe go without that UI and just simply log to a file. So I can basically turn it on, start logging to a file, flip on the system that I want to debug, let it run for 10, 20, 30 seconds, turn it off, and then go back and pull up that log data and peruse my way through it. Which means I'll need to update my Windows app to support that, opening a file instead of just live coming in sensor data through serial. But I think that's a pretty minor effort to do at some point. So I think that's where I'm going to stop this video. Well, what might actually be kind of fun is to see if I could connect this to my 386. So what I'm going to do is maybe not in the video here, but I am going to stop this and come back in and connect this card to my 386 and see if I can read out 32 bits of address data. That might be a pretty interesting test here to see. That will also help me validate if this connector is going to work at all. So again, this little card is going to plug into this connector, and I may or may not have that properly done. So that'll be a good test here. So I'll be right back. Okay, I've pulled off what I had up on my workbench. I brought back up my current build of my 386 upper board, the lower board. Again, I've got this Teensy debug board, and then this little signal acquisition board that I've got. So I'm going to go ahead and get my upper and lower boards connected together real quick. So like that, and then I've got this just little tether for power. And then this, I'm going to basically just be able to plug in to this, and that goes in nicely. We'll see if just sitting there like that is going to be any problems in the future. I don't have anything that physically holds it more than just the little PCI Express slot. So that may be a problem later, and we'll see how that goes. Also, these slots are only rated for so many insertions, and I don't know what the number is, maybe 100 or something like that. So if I'm going to do a lot of in and out on these boards, that of course will be a factor at some point. So let's see, let me get power plugged in here. Maybe one other change I've made, if you've been following the videos, I did add these basically resistors. They were on the board, I just didn't have them populated last time I was doing some testing. And I had a video I posted when I was first turning on the system. It was pulling more power than I thought. So these have been added. I've not tested the system with these in here yet. But these are 3.3K, and I'm just simply pulling to ground. I have a jumper here whether I pull up or down. So these are all just doing pull downs on all of the address and data signals. So there's 64 of them. Okay, so this is here. This is still running, I guess. If I go over to my screen and just clear this output, you can see it's still constantly reading whatever values are coming from that. And I guess I want to fire this up and see if anything bad happens. Okay, so it is reading some values. That is good. Right now, the clock that I'm running, I need to hook up yet. So I do need a clock here. So I'm going to turn this off. Okay. So power there, power jumpered over to this board. This board is going to provide my clock signal. Okay, and you can see over to the right, I'm reading a bunch of FFs. Now I'm not reading very fast here, and on this I'm only reading twice a second, so I'm delaying half a second in between. But I just kind of want to see, is it reading values? And it looks like it is reading values, so that may be good. I don't know yet if those are values I want to be seeing. What I am going to do, though, is maybe take this delay and flip it to a much slower or lower number, so less of a delay, so it reads the values more rapidly. Okay, so let me see if I was to turn off the system. It's all zeros. Turn it on. I'm reading a bunch of Fs. It's going through the normal processor initialization, which takes a little bit here. But then I can start to see that it is jumping to some different addresses. Now, I have to also keep in mind I don't have this code done yet, so that would be an oversight on my part. So let me just comment this out and bring this back. And I am going to, for now, I can put this down here, I suppose. 8. So I'm going to have a buffer of 10 characters. I'm going to populate that buffer with 8 hex characters based on whatever is in address 32. And to get to that, I'm plugged into this port right here, so I know I need to be looking at shifters 15, 16, and then probably 13, 14. And so I'm going to go shifter 13, 14, 15, 16. So before I was plugged in and testing shifter 15, 16. Now I'm going to test 13, 14, 15, 16 because I should be able to grab all of those. And then I want to take this first one over 31, 23, 15, 7. That looks, I think, right. Let me go ahead and run that. And I'm going to turn off the 386 in the meantime. Okay, and so now I'm reading the address. That should be a 32-bit address. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so that should be my 8 hex characters. And I turn it on and I can see what it's looking at, and I'm thinking I might have some of these backwards. Normally when I turn it on, I expect the FC to be at the far right, and so I might have these shifter numbers backwards. So I'm going to turn it off. My 386 is off, and I'll have to go back and just double check this later, but maybe the way I've got it coming out of, well, it's how I have it plugged into here is what really matters. And I'm just guessing by looking at the pattern on the output. I just need to flip these around. So let's try it. Okay, I'm going to go ahead and fire up the 386. And okay, now I've got an FF, FC is where it's kind of set during its initialization. That's what I would normally expect. And then of course I wanted it to jump to, yeah, F0. Okay, actually that, what I was seeing for code doesn't look, or for addressing doesn't look terribly bad. So I'm going to go ahead and turn it off for a second. And I'm going to turn it on, and then I'm going to stop this logged output once it gets past the point I'm looking for. So let's go ahead and turn it on. It's initializing. What I would expect to see, there's FFFFFFC. That looks good. And then of course I wanted to go to F0 at the very end, and then from there eventually get over to my 8000 or C000. But I'm going to stop right here. Okay, so if I just take a quick, gander at this, it seems like it did go. Oops, I did not want to do that. I'll scroll. Let me disconnect this. Okay, so if I go back up though, it got to my F. Cooperate. Let's see. It got to my. It went from my FF. I'll just say FFFC for those last 4. It went to FFF0. That's good. It read the 4. It read the 8. And then there's some stuff there that is probably not even valid information. But then after that, what I want to be able to get to is the address that I would have read. And that's what I now need to do next, is get it so that I can read the data, so that I know what did it read from FFF0, because that's going to tell me whether or not it actually, my shadow got copied over into RAM. And so I need to get one more of these populated. I need to read the address data so I can see what address data did it even read at F0. And then it read F4, it read F8, and then it's trying to do a jump to something. And, I see it got over to some address here that doesn't quite look like what I would expect it to look like at that point. So I'm guessing something didn't read the way I wanted it to for data, or this initial, what my PSOC is trying to take ROM into RAM. Something isn't right with the new build. It could be a lot of things, so I'm not even worried about it, but that will be troubleshooting I'll do as I get more of this debug stuff filled out. But I think this appears to be working, and I'm going just off the fact that it looks like it went from the FC to the F0 to the 4 to the 8. That's what I would expect to see. And then I would expect it to jump to an address, and I'm guessing this is what it tried reading off RAM. So there's something with that RAM read, or the population of ROM into RAM, that might not be quite right yet. So in a future video, you'll see me do some troubleshooting then next with this, with the rest of these 4 populated, and get back to that user interface, the Windows user interface that I've been using to read those values. And then I can see how close or how far I am from having some actual ROM code run on this system. If there's, just something really off in the way I've got this set up. Again, this hasn't changed much, or shouldn't be much different than what I had in my previous proto board, but there might be something that during the initialization is a little bit different on this one. Again, this one's pulling higher power than I would expect it. But step 1 towards debugging, good to go here. So more to come in the next video, more debugging, and we'll see how that goes.